morning, one and all. Anyway, good evening, all of you. So, my name is Krakarla Krishna Kishore. I am professor in mechanical engineering. So, today we are going to discuss the mechanism and types of creep. So, what is exactly the mechanism behind this creep? What is happening behind this creep? See, all these things we are going to discuss in this session. See, without understanding this creep technology, without understanding the deformation which occurs due to the creep, we cannot design some of the material. We cannot enter the materials, whatever the materials produced by you, you cannot enter your material in this world without understanding this creep. So that's why understanding creep is very important, and which gives the vast knowledge to understanding the properties, how it behaves, why it is deformed. Suppose if you apply the load, so what type of load you are applying, you must have lot of clarity regarding this particular creep. Without understanding creep, without creating the deformation mechanism, without understanding the deformation mechanism, you cannot understand the properties of the material and you cannot launch your material in this world. See, let us discuss the discussion of the mechanism and types of creep in this session. Now, let me explain the creep first. If you are able to understand the creep and the various mechanism behind the creep, then you can understand what is happening behind the creep. So let me discuss. Now, what is exactly the creep? See here, try to understand the deformation that is which occurs due to the creep here. Creep is a deformation mechanism that may or may not constitute a failure mode. So please observe this word here. This particular creep is a deformation mechanism. Definitely due to the creep we are going to get, that means the material is going to get the creep, but it may not be a failure mode. So that means it may not leads to the failure. Definitely the material, whatever the material that you are going to observe, the creep, it will have the deformation mechanism, but it may not leads to the failure mode. So that means it is having some stages. We have to understand the stages that are observed due to the creep here. Now, that is unlike the brittle fracture. So here you can see the brittle fracture. Various brittle fracture you can observe. Brittle means, what do you mean by brittle? Brittle means a sudden failure. Sudden failure without having any deformation, without having any elongation. If any material is observed, the crack, then we can say that it is a brittle fracture. Here, unlike its brittle fracture, the creep deformation does not occur suddenly. So please try to understand this particular point here. Creep deformation does not occur suddenly. If it is a brittle fracture, it will occur, definitely it will occur suddenly. So that means without giving any signal, the brittle fracture will be observed in any material. Suppose if you apply the load without having any elongation, after some time, if it bears, any material can bear up to some extension, but after that it leads to the brittle, it leads to the crack. So that type of crack is represented as a brittle fracture, but the creep is not like that. Anyway, we are going to see some of the images and some of the stages, how the creep is going to observed in the material in the next coming slides. Now, this creep deformation does not occur suddenly upon the application of the stress. This point you have to remember. Instead, strain accumulates here. So as a result of long-term stress, here we have used one word here that is represented as a long-term stress. What do you mean by long-term stress here? The name itself, it is giving some information. It is a long-term stress. Means we have to give the stress for a longer period of time. So that means it may be 1 day, it may be 2 days, it may be 6 months, sometimes it may be 1 year. So up to some time, that is some extent of time, you have to give the stress on a material. After applying that much stress, that means a longer period, so automatically the material under strain. So then only the material may have some particular strain or some particular crack may be observed due to the creep. So this is a longer period, so that means we can say in a shortcut, that means in a single sentence, if you want to say the creep as it is a time dependent strain occurring under stress. So that may be the definition for the creep. Now let me discuss the various salient features. So here we can say that the creep is a time dependent deformation. So that means which plays a vital role. What is the main role of the deformation that is observed due to the creep here? So here the time, so that means time plays a vital role in deforming the mechanism of any material. Now let me discuss the various stages of the creep here. Now, what are the three stages of the creep? See, actually the creep is observed due to so many number of stages, but the primary stage. So that means in initial stage, we can say that the three stages of the creep is existed for some extended period. Now, the first stage, what is the first stage, what is the second stage, and what is the third stage of the creep? So now let me explain here. So in general, three stages are existed. The creep, for a creep, in general, three stages are existed. The first one is represented as a primary creep. So primary creep starts at an increased rate and slows the time due to the material hardening. So try to observe the sentence form here. The primary creep means it starts an increased rate and slows with time due to the material hardening. So this is the primary creep here. Now, after primary creep is completed for a particular period of time, now the secondary creep starts, has a relatively steady rate. So that means after primary creep is completed, now the secondary creep is going to start. So this is represented as a secondary creep. Now after secondary creep is completed, then the third stage is going to start, which is represented as a territory creep or third stage of the creep, has an accelerated rate. Here, whatever the third stage, if you observe the third stage of the creep, so in this creep, that is in this stage, it is accelerated. The rate is accelerated. The creep rate is accelerated and ends when the material breaks. So that means the failure at the end of the territory creep, that means at the end of the third stage of the creep, the material is going to have the crack. So let me show how this particular stages are observed in a graph. So this is the graph versus strain versus time. Please observe the graph here. This is the graph between strain. The y-axis shows the strain. The x-axis shows the time. Here up to some period, so it is represented as an elastic strain here. After that, it is represented as a primary creep here. After that, it is a secondary creep. This is a secondary creep. Then it is a territory creep. If you observe here, at the end of the territory creep, that means at the end of the third stage, the fracture will be observed. If you observe the secondary creep, it is almost, the strain is almost constant. So now let me show how does this creep is going to occur. See, if you able to understand the creep in a proper manner, automatically you can say that the various material properties and how you can assess why this particular material properties are changed and when the creep crack is going to observe. But if you want to analyze all these things, you must have the clear data regarding creep, when this is going to observe and how this particular creep is going to occur. Now let me discuss like this, how does creep occur. See, consequently creep failure, whatever the stages that you have observed here, this is called as a creep failure, that the creep failure is going to observe at the third stage. This creep failure or the creep fracture, so these two observed simultaneously of a member may occur over a wide range of the temperatures. Here the main important that is factor that you have to understand is the temperature. How much temperature that you have given to the material. So that is represented as a load. Here the temperature is considered as a load here. And how much load you are giving and how much time you are keeping that material under that temperature. So that means here if you give the temperature to a material, maybe suppose assume that 500 degrees you are giving to the material. Suppose if you are giving 500 degrees to the material, how much time you are giving that temperature to the material? Whether it is a 1 day or 6 days or 6 months, how much time you are giving? So how much time the material has to bear? Suppose if it sometimes some material may bear that particular temperature maybe for 1 day, maybe for 2 days, maybe for 1 week or maybe for 6 months. So depends on the material ability, the material will bear that particular temperature. So that means we can say that that temperature load some material can bear for a longer period of time. So depends on the material strength. So we can say that the ability of the material, the strength of the material, we can assess what is the ability of the material. So that means we can say that the creep will occur in any material, that is in any material or metal subjected to a sustained load. Here this particular word is important, sustained load. How much that is load it will able to bear. So sustained load at a temperature slightly above its recrystallization temperature. See the whatever the load that you have to give, that is the temperature load, it is slightly above its recrystallization temperature here. So when it reaches its recrystallization temperature, that is just above the recrystallization temperature, then automatically it cannot bear. At this temperature the atoms are going to move. So this is the procedure, and we can say that this is the process how the creep is going to be observed or how the creep is going to occur in any material. Now we can see the creep behavior, so that we have seen in the earlier graph here. Please observe the graph here. The red line shows the stage 1 as I have discussed in the earlier slide. So initial state. So that means for a material, first of all, you have to say that you can say that the initial strain is observed. So up to that, the strain 1, we can say that this is the stage 1 here. You can see this is the stage 1, and you can observe the stage 2. How much longer period, that means how much time it has taken. And you can see that this is a minimum creep rate. So that means the change will be observed only a minimum change. You can observe here the horizontal line change is only a minimum. So with this line, that is with this graph, you can clearly say that only a minimum creep rate will be observed in stage 2. So that means we can say that it exists a minor change in stage 2. So if you observe stage 3, so you can observe here the maximum change, and at the end of the, that is stage 3, you can observe the fracture. The fracture will be observed. So now see here, what is this creep state? Here you are seeing that these are called as an initial strain, and here we can say that the creep strain is observed. We are saying that the creep strain is observed in the material. If you are saying that creep strain is observed in the material, what is this exactly the creep strain? And you can see on the y-axis, so we are saying that it is a strain. So it is called as a creep strain. So what is exactly the creep strain? So let me discuss what is a creep strain. Please observe in initial stage, whatever the stage that you have observed, in initial stage or primary creep or transient creep here, the strain rate is relatively high. So that means in initial stage, that means when we are giving the strain to the material in initial stage, which is represented as a primary creep, the strain rate is relatively high. Now after that, that means after that, but decreases with increase in time and strain. So that means when the time increases, that means increase of time, automatically the strain is going to be decreases. Now let me discuss in the detailed manner how this creep strain and what is this creep strain. So due to this process analogous to work hardening at lower temperature. So this particular sentence is very important in understanding creep strain here. Now you can observe the same in another manner. Instantaneous deformation, primary, you can observe here this is the line. With the help of this particular line or with the help of this particular triangle, we can calculate the creep rate. That means the slope. With the help of this slope, we can calculate how much creep, say what is the creep rate is going to be observed in the secondary crack here. That is our secondary stage or the second stage of the creep. So you can say that it is a creep strain versus time. And to understand this particular creep strain or to creep, say crack, so how this particular test is going to work? Is this test is going to work? Whatever the creeps that we are saying here, is this particular test is going to work? So let me discuss how this is going to work. See, whatever the creep test, whatever the test that you have observed on the material, the results of the test are usually plotted as strain versus time. As you have seen earlier, this is all the graphs are strain versus time up to rupture. Let me repeat this sentence here. Results of the test, whatever the creep test that you have observed on the material, all those results you have to conduct until the rupture will be observed. So that means whatever the material you have taken, so after giving some heat to the material, after giving some temperature load to the material, so you have to give the material that is a temperature load until the material is observed rupture. So this particular third stage is very important if you want to conclude the test here. Now here as indicated in the image, that means you have seen the image strain versus time. The creep often takes the place in three stages here. So you have to understand the creep here. It will be observed in three stages. In initial stage, as we have discussed, the strain occurs at a relatively rapid rate, but the rate gradually decreases until it becomes approximately constant during the second stage. So here, if you want to understand the creep test, the second stage is almost, it is a constant. Now like this, the creep test you can observe, this is already we have seen. Now let me discuss in another manner. You can observe here. Please observe the graph here. These are isolated cavities at various places. If you observe this graph here, this graph clearly shows how the cavities are going to increase from secondary stage to third stage. So that means how these cavities will lead to the crack. First observe at the second stage, in the primary stage, we can say that there is no cavities, there is no crack in the primary stage. But if you observe at the third stage, that means at the end of the second stage, the isolated cavities will be observed here. That means isolated cavities are observed, and after that all these cavities are aligned in the grain boundaries. Please observe here. So you can see the grain boundaries, and on those grain boundaries all these cavities are aligned like this, and these cavities are increasing. That means when the temperature load increases and when the time increases, that means after some time, maybe after 1 day, maybe after 2 days, maybe after 3 days, or maybe after 1 week, if you are giving continuously this type of they say temperature load to the material, automatically what will happen? The cracking will be observed. Slowly the cracks will be observed in the material. So here you can say that these cracks are micro cracking. Sometimes we cannot see all these cracks with the help of naked eye. You have to see this type of cracks under the micro cracks. That is microscope only we can see these type of cracks. You can see here at the end of the third stage, you can say that there is a micro cracking. So all these are explains how the creep is going to be observed in the material and why the particular creep has to be studied. See, if you able to study this particular creep crack analysis, automatically we can say that at what temperature, at what time the material is going to be observed the crack. I repeat, at what temperature and at what time the material is going to have the crack. So this is called as a creep strain. So because of this creep strain, the material undergoes creep crack here at the end of the third stage. Now let me discuss the mechanism. See, now up to now we have seen the creep cracks here and how the creep crack is going to be formed and what are the stages of the creep and how the creep is going to crack, that is how the crack is going to be observed at the end of the third stage. Now let me discuss the mechanism of creep deformation. See, there are so many deformation mechanisms are observed. Let me discuss the main mechanism deformations which are observed and which are main causes of the creep deformation. So let me discuss like this. See, strength, whatever the strength that we have seen in the material, strength is automatically quickly lost in this stage, that is the third stage, while the material shape is permanently changed here. So that means if the creep is absorbed by the material, strength is automatically lost. And the acceleration of creep deformation is a tertiary stage eventually leads to material fracture. So this is the point you have to observe and the mechanism of creep. See, what are the mechanism that we are going to discuss now? So that mechanism of creep depends on the temperature and stress. Let me repeat these two words here. The mechanism of the creep depends on the temperature and stress here. So that means the temperature and stress plays a vital role in giving the creep crack here. So what are the mechanisms here? As I said earlier, lot of mechanisms are available. See, in this session, we will discuss the various mechanism and the types of mechanism of the creep here. Now let me discuss the creep mechanism here. Please observe the words which are very important. First one is dislocation creep. What is dislocation creep? We will discuss in this session. And what is Nabarro-Herring creep? So this is very important creep which is observed in the material, and the Coble creep. So this is another important creep mechanism, and the cracks are observed due to the Coble creep. So this is the another mechanism, and the dislocation climb glide creep. So these are the various creep mechanisms which are observed in the material. See, try to observe these three, that is four mechanisms: dislocation creep, Nabarro-Herring creep, Coble creep, and dislocation climb glide creep. So these are the four different type of creeps which are observed in the material. So let me discuss in detail what is dislocation, what is Nabarro-Herring, and what is Coble, and what is dislocation climb glide creep with the help of some images. Now let me discuss the first one, dislocation creep. First, observe the image first. Observe the image in a proper manner. Assume this is a material. Assume this is a material. Observe carefully. Here you are observing the two images here. The actual practice three images. This is the first image. This is the second image. In the first stage, when the load is not applied, the structure will be like this. And the atoms are having their own places, and atoms occupied by its own places. There is no dislocations in the initial stage. So that means when there is no creep, when there is no load on the material, this will be the structure of the material. Now, if you apply the tensile load, please observe the material here, the left side image. If you apply the tensile load in all directions, so like this, the material will be observed some deformation in this direction. So that means in upward direction the material will deform, in downward direction the material will be deformed. So due to this, some dislocations, you can see here, the atoms may be displaced from the particular location. So because of this, the deformation may be observed. I repeat, the deformation will be observed because of this dislocation. See here, this is one dislocation, this is another dislocation. All these dislocations may be observed because of the load is applied on the material, because of the continuous load is applied on the material. In another word, we can say that sometimes constant load. Here in creep, the main point we have to observe is constant load is observed on the material. Here, if you observe the sentence here, the dislocation creep involves the movement of dislocation. What are the dislocation here? This has to be moved from one particular point or one particular location to the other location. When this dislocation moved from one location to the other dislocation through the crystal lattice of the material, in contrast, we can say that it is diffused. That means the creep is going to be diffused, and in which the diffusion, that means the vacancies are dominant. That means the vacancies are going to dominate in the material. Automatically after sometimes it leads to the creep, it leads to the crack. I repeat, whatever the dislocations are observed in the material, these dislocations are leads to the creep here. So if the creep crack is observed, or if the crack is observed because of this dislocation, we can say that this is represented as a dislocation creep. The crack is observed because of these dislocations. We can say that that dislocation or that creep crack can be represented as a dislocation creep. Now let me explain. You can see in another image, atoms are mixed here. One entire row is mixed here. You can observe. Now you can observe how the dislocation is going to have the change, or how the dislocation is going to move from one place to another place. See, in initial stage, suppose sometimes atoms are total. So you can see the black color here. You can see the atoms are misplaced here. So this particular dislocation, whatever the atoms misplaced, that is the dislocation, is going to move from one place like this, migration of dislocation. When you apply the load, that means a constant load is applied on the material, so this will be moved from one place. You can observe here, you can observe clearly, you can observe in a clear manner the atoms are moved from one place to another place like this, and automatically the crystal shape has changed without mechanical fracturing or loss of crystal structure. So that means here these type of dislocations may be observed in so many number of materials. You cannot, sometimes crack may not be observed. That means crystal structure will have these type of dislocation. That means internal dislocations may be observed. But when will it leads to the crack? That means it leads to the crack if it having a continuous load. If a constant temperature is going to have, or constant temperature will give the material a creep crack. So until it leads a major crack, then only it will be observed by the microscope. Now you can observe here the second one. Up to now we have discussed the dislocation creep. The crack will be observed due to the dislocation creep. Now what is the Nabarro-Herring creep here? Now please observe the grain boundary here. First observe the image here. After that we will discuss what is the Nabarro-Herring creep. It is very important, and if you are able to understand this Nabarro-Herring creep, we can avoid, or at least we can say that how much deformation is observed by the material, and what type of deformation is observed by the material, and what is the result of this particular deformation, whether it is a dislocation creep or whether it is a Nabarro-Herring creep or any other creep. So that means you must have a clear information regarding these type of creeps here. Now let me discuss with the help of this image. This is the grain boundary. You can observe these are the locations, these are the vacancies, vacant source here, and here all these vacancies are distributed throughout the grain boundary. See, it is not distributed only on the grain boundary, this is the grain boundary, but these vacancies are throughout this particular grains here. So these type of that is diffusion of vacancies or diffusion of vacancy sources are synced to the grain boundaries. We can say that this is a Nabarro-Herring creep. See here, the sentence clearly says that the Nabarro creep, that is herring creep, is a mode of deformation of crystalline material, or you can say that it is amorphous materials that occurs at low stresses. That means low stress is enough to give this type of Nabarro-Herring creep here, and held at elevated temperature. Here, the type of Nabarro-Herring creep will be observed at elevated temperature in fine-grained material. So that means dislocation creep is a different issue, and this Nabarro-Herring is a different creep crack here. This will be observed at elevated temperatures and at fine-grained materials. So this is very important creep compared to any other creep crack, and this type of creep crack will be observed in the grain boundaries. Anyway, we will compare this Nabarro-Herring creep with other creeps also. You can see this is a Nabarro, NH stands for Nabarro-Herring creep. This is the grain interior. This is a grain boundary. If you observe the material strain, that is the stress is observed. Now, in what direction the grains or the vacancies or the material will be absorbed are the strains. See here, this is the direction in which direction the material will absorb the strain. This is called as a Nabarro-Herring creep. Now, the third one is Coble creep here. This is the Coble creep. This particular Coble creep is the third Coble type of creep. This is having somewhat different from the Nabarro-Herring creep. So let me discuss. So this creep is a form of diffusion creep. So diffusion means it distributes throughout the material and throughout the grain boundary. And this particular Coble creep occurs through the diffusion of the atoms. So that means a distribution of the atoms in a material along the grain boundaries. Please observe this sentence here. When compared to the noble herring crepes is distributed throughout the grain, but this Coble crepe is not going to distribute throughout the grain. It only occupies along the grain boundaries. I repeat, this Coble crepe will be distributed only along the grain boundaries only. So that is the main difference between this particular Coble creep and noble herring creep here. Now, let me discuss in another manner this mechanism. What are the mechanism that you are seeing here? This is observed in polycrystals. In what material that you are observing in Coble creep? That means Coble creep, as we have said that the Coble creep is observed in grain boundaries only. And if you observe the noble creep, that is a noble herring creep, that is observed throughout the grain, but it is observed only through the grain boundaries. And it is observed in polycrystals. That means if a many number of crystals are observed, this Coble creep can be seen in those polycrystals or along the surface in a single crystal. If it is a single crystal along the surface, if it is a polycrystals, it is along the grain boundaries, which produces a net flow of the material at a sliding of the grain boundaries. This is the result of the Coble creep here. You can see the comparison between Nabarro-Herring creep, that is which is represented as a diffusional creep, and Coble creep here. You can see the clear difference between Nabarro-Herring diffusion creep and Coble creep here. Please observe, this is the grain boundary. This is a grain boundary here. This is another grain. This is another grain. Vacancies are created along the grains. But if you observe Nabarro-Herring creep here, the vacancies are created throughout the grains here. That is the main difference. Here in NH creep, that is Nabarro-Herring creep, the grains are created, that is vacancies are created throughout the grains. but here it is created only along the grain boundaries. This is the grain boundaries, and after load is applied, you can see the difference. This image is before the load is applied, and this image is after the load is applied. After the load is applied, here the NH creep, that means this NH Nabarro-Herring creep, you can see all the vacancies are distributed like this. Now here how the distribution is going to be observed in Coble creep. Please observe. This is the Coble creep distribution only along the grain boundaries, but here this vacancy distribution, that means the deformation, will be observed throughout the grain boundaries. That is the main difference between NH Nabarro-Herring diffusion creep and Coble creep. So that means if you observe at the microscope, you can observe this Coble creep deformation in the grain boundaries. If you observe this NH creep, you can observe through the, that is in throughout the grain boundaries, that is the throughout the grains here. That is the main difference. You can observe this is the Coble creep, this is a that is the Nabarro-Herring creep here. Now the next one, the creep is, that is this type of mechanism, that is this type of creep deformation is represented as a dislocation climb glide creep. Please try to observe the name here. This is dislocation climb glide creep. The name is giving some information here. This is a dislocation climb. So that means the dislocation is going to climb, the dislocation is going to glide. That means it is going to slide in a particular material. So how it is going to form, how it is going to have some differentiation compared to the other, that is an Nabarro-Herring or dislocation or any other Coble creep. Please observe the sentence here. The mechanism of this dislocation climb consists of vacancy absorption. Here this particular creep is absorbed in the material by vacancy absorption by the dislocation core here. That is the main information regarding dislocation climb. And as the vacancy is absorbed, so that means this particular creep is going to be absorbed in the material by vacancy absorption. This vacancy, what is, whenever the vacancy is absorbed, the core of edge dislocation move one atomic space and one lattice atomic, that is position is going to be lost. So anyway, we will see with the help of some image here. Please observe the image, how the dislocation climb is going to be observed here. This is the atom place here. This is the atom is lost here. When we apply the load on the material, it may be a temperature, it may be any other material, that is any other load on the material, a constant load is observed on the material, maybe compression, maybe tensile. This particular dislocation is going to have the climbing, this dislocation is going to have the gliding. So that means one place to another place here. So automatically we can say that this is called as a dislocation climbing, dislocation gliding. Now you can observe, it is clear that there is no kinematic constraint here. There is no constraint here restricting the climbing motion, and in one direction dislocation climb or descent here. You can see here, this is a position, a vacancy diffuses to the position of atom B, causing the dislocation to glide. See here, this is the initial position of the climbing, this is the next position. See the difference here, this is the initial position of the diffusion, this is the second position of the diffusion. How it is going to climb. You can see in another image, strong dependence upon stress here. You can see whatever the dislocation types, that is mechanisms, dislocation glides or dislocation Coble creep or Nabarro-Herring creep or whatever. So all these having some values here, the tensile stress, at what tensile stress See, this particular graph, it clearly shows at what temperature and at what tensile stress the particular dislocation will be observed. See, this information is important at what temperature. Suppose if you observe the theoretical stresses, see this is the line which shows at what stress the particular elastic region is going to be observed and what temperature and what. See, what is the position of the dislocation creep here? See, you can see at this temperature the dislocation creep is going to be observed. The Coble creep and the Nabarro-Herring creep. So here depends on this particular temperature information. You have to give the temperature, that means the load to the material, so that you can have a clear picture at what temperature, that means at what load the material will absorb the crack. That means before going to crack is observed in the material, you can clearly assess how much time will be taken by the material, at what time the material is going to have the crack, at what load the material is going to have the crack. So this type of information is very much needed to observe the properties of the material. If you are able to observe this information, if you have the guess of this information, automatically we can use the material as a end material. So for any, suppose if you are using the material as a gear, that is if you are producing the gear by utilizing your material, then we can say that this material going to have the crack after some time, maybe after 1 month, maybe after 1 year. So this type of information you can give to the customer depends on the creep information, depends on the creep crack information. So this information, whatever the information that we have discussed in this session, is very much useful to understand the behavior of the material, the creep behavior of the material, the creep mechanism of the material. So without this information, we cannot understand what is the main crack is going to observe, how much time will lead, that is how much time will be taken by the material to give the crack in a particular time. That means how much time it can withstand, how much load it can withstand, what is the strength of the material, what is the primary stage of the material, what is the secondary stage of the material. So all this information is important for any material to understand the creep behavior. So this is all about creep information. With this information we can say that this mechanism is very much useful to understand the creep behavior. So this is from my side. If you have any doubts, you can post your doubts in chat box. Anyway, I'll give reply to your doubts. Now this is all about the various mechanisms and the theories of the creep types or creep cracks here. Now with this information, I am closing the session. In the next coming session, we will discuss a lot of other materials or other information and other types of various deformation and the material types and the material deformations in coming sessions. So this is Kakala Krishna Kishore signing off. Thank you one and all.